In 1912, a groundbreaking discovery was made that would forever change our understanding of the universe. The scientist behind it, someone you've probably never heard of. While men like Einstein and Hubble became household names, this astronomical genius was paid just 30 cents an hour to do what was dismissed as women's work. Yet without her, we wouldn't know the true size of our universe. This is the forgotten story of Henrietta Swan Leavitt, the deaf astronomer who gave us the key to measuring the cosmos. Born in 1868 to a Massachusetts church minister, Henrietta Swan Leavitt grew up with an insatiable curiosity about the night sky. At a time when most women were expected to become housewives or teachers, she pursued higher education at Radcliffe College, then known as the Society for the Collegiate Instruction of Women. But fate had other plans. During her studies, she began experiencing progressive hearing loss, a challenge that would eventually leave her completely deaf. Many would have seen this as a career-ending setback. For Henrietta, it only deepened her connection to the silent language of the stars. In 1893, she volunteered at the Harvard College Observatory, joining a group of women known dismissively as Pickering's Harem. Named after the observatory's director, Edward Charles Pickering, these women were hired to do the tedious work of cataloging stars, computing their positions, and analyzing their brightness in thousands of photographic plates. They were essentially human computers, paid less than half what men earned for similar work. But in this mundane task, Henrietta would find her calling. Day after day, Henrietta sat hunched over photographic plates, examining countless points of light captured in the darkness. Her job was simple: measure and catalogue the brightness of stars. It was considered appropriate women's work, detail-oriented but not requiring any real scientific thinking. Or so the men believed. Her growing deafness isolated her from colleagues, forcing her to focus intensely on the glass plates before her. The male astronomers got to use the telescopes, make observations, and publish papers under their own names. The women, they were barely acknowledged in footnotes. But Henrietta saw something in those endless dots of light that everyone else had missed. Working with variable stars, stars that change in brightness over time, she began to notice a pattern. It wasn't easy to prove. She had to measure thousands of stars in the small and large Magellanic Clouds, painstakingly recording their periods of brightness and dimness, all while fighting against the dismissive attitudes of her male colleagues, her declining hearing, and the tedium of her assigned tasks. Many of her colleagues simply catalogued the stars and moved on. Henrietta kept digging deeper, driven by a question that had puzzled astronomers for centuries. How could we measure the true distances to the stars? In those thousands of glass plates, Henrietta discovered something revolutionary. Working specifically with Cepheid variable stars, she noticed that the brighter ones had longer periods of pulsation. This wasn't just a casual observation. It was a precise mathematical relationship. Stars that took longer to cycle through their brightness changes were inherently brighter than their faster cycling cousins. This period-luminosity relationship became known as Leavitt's law. But its true significance was even greater than it first appeared. Because if you could see a Cepheid variable star and measure how long it took to cycle through its brightness changes, you could calculate its true brightness. And if you knew its true brightness, you could figure out its distance from Earth by comparing how bright it actually appeared. It was like discovering a cosmic yardstick. Think about that for a moment. In an era before computers, before digital imagery, before modern telescopes, a deaf woman working for 30 cents an hour found the key to measuring the universe. She published her findings in 1908 in the Annals of Harvard College Observatory. The publication noted that the discovery was made by H.S. Leavitt, hiding even her gender from readers. But her discovery was about to change everything we knew about space. When she identified this relationship among 2,400 variable stars in the Magellanic Clouds, she provided astronomers with the first standard candle, a way to measure vast cosmic distances. This was the breakthrough that would allow Edwin Hubble to prove that the Milky Way wasn't the entire universe, but just one galaxy among many. It was the key that unlocked our understanding of the true scale of the cosmos. Despite the monumental importance of her discovery, Henrietta remained largely unknown outside of astronomical circles. While others used her work to make groundbreaking discoveries about the universe, she continued her modest work at Harvard. Still cataloging stars, still earning minimal pay. Her hearing loss progressed until she was completely deaf, further isolating her from the scientific community. When the Swedish mathematician Gösta Mittag-Leffler learned of her work in 1925, he wanted to nominate her for the Nobel Prize in Physics, but it was too late. Henrietta had died of cancer 4 years earlier at the age of 53. The Nobel Prize cannot be awarded posthumously, while men like Edwin Hubble went on to fame and recognition, building upon her discovery to revolutionize our understanding of the universe. Henrietta's name faded into obscurity. Her groundbreaking work was often attributed to others or mentioned only in passing. The astronomy community, dominated by men, was slow to recognize the true genius of her discovery. Even today, many astronomy textbooks give only a brief mention of her contribution, if they mention it at all. Her story became a footnote in the history of astronomy, her brilliance overshadowed by the very men who built their careers on her discovery. But Henrietta Swan Leavitt's legacy cannot be erased. Her period-luminosity relationship became the foundation for measuring cosmic distances, allowing us to understand the true scale of our universe. Without her work, Edwin Hubble couldn't have discovered that the universe extends far beyond our galaxy. We wouldn't know about the expansion of the universe. Our modern understanding of cosmic evolution and the Big Bang Theory might not exist. Today, as we mark a new era of space exploration and astronomical discovery, Leavitt's work remains fundamental. The James Webb Space Telescope, our most powerful eye on the cosmos, still relies on the principles she discovered. Her story resonates powerfully in our current moment. As we continue to grapple with gender discrimination in science and technology, the next time you look up at the stars, remember Henrietta Swan Leavitt. Remember the deaf woman who, despite every obstacle, gave us the key to measuring the infinite. Remember that groundbreaking discoveries can come from the most unexpected places, from people society has chosen to ignore or forget. In the end, her story isn't just about astronomy, it's about persistence, about seeing patterns where others see only points of light, about changing our understanding of the universe while working for less than a living wage. If you've been moved by Henrietta's story, share it with others. Let's ensure this forgotten genius finally gets the recognition she deserves. And make sure to follow us for more stories of the brilliant minds history tried to erase. Because, in the end, the universe doesn't care about your gender, your disability, or your social status. It reveals its secrets to those who have the patience, persistence, and brilliance to look closely enough. Henrietta Swan Leavitt proved that, and a century later, her light still shines, guiding us through the cosmos. She helped us understand